Well, good morning. How are you today? We are going to be doing lesson 21. This is a 2-day lesson, and make sure you watch the Eureka video before you start. I think you'll find that what we're going to do is pretty easy, except for one little thing. Even after you watch the Eureka video, you might have to really dig into your brain pan to remember how to do this particular problem with Katrina and her 23 stickers and Jennifer with her 9 stickers. I'm going to just give you a little hint on this problem because you are going to have to remember, do you, wait a minute, I'm just going to do this. I'm just going to take this and show this to you. If you are going to be successful on this problem today, I'm going to ask you, do you remember how to decompose a 10? It's been just a bit since we decomposed a 10. I'm hoping that you remember how to do it. So if you're struggling with this one, I'm just going to remind you that you need to remember how to decompose a 10 in order to be able to solve it. We will talk about it in just a few minutes. And after you've had a chance to watch the Eureka video, which they, by the way, don't talk about it in the video, but anyway, make sure that you use cubes and read, draw, and write. And I will get back to that problem in a couple of minutes. Also, be sure that you do this part of the test where you write your statement that matches the story, which is the W part of the read, draw, and write. All right, so then on day 1, you're going to do problems 1A and B, remembering to take all the steps that you need to do, very similar to what we did yesterday, using the chip model and your place value chart on both problems, and then your exit ticket for problem C, and sending that one to your teacher. It's kind of a short lesson today. Make sure you watch the video and see if you can remember how to be able to decompose a 10 in order to be able to solve this problem. So I am going to pause my video, or you're going to pause the video and do what you need to watch the Eureka video, try and solve the problem application and the other problems that you need to do, as well as sending your exit ticket for today. And with that, I'm going to say, pause the video. All right, so here we are back, and I am going to go through these problems with you and see how well you remembered how to decompose a 10. So we started off with Katrina, who had 23 stickers, and Jennifer, oh dear, that is so hard to read. Oh, that's a little bit better. Katrina had 23 stickers, and Jennifer had 9 stickers. Circling the numbers, boxing these keywords, how many more stickers does Jennifer need to have the same number as Katrina? Well, I set this up as a vertical equation as my whole take away a part equals a part. So then I set up my tape model or my bar model with 23 stickers, which is the total number of stickers that Katrina had. We have Jennifer, who only has 9, and our question that we're trying to solve is how many more are needed for Jennifer to have the same number as Katrina. So that would be 23 take away 9 equals, of course you can see the answer there because I've already worked this problem out. But here's the big question. I'm hoping you remembered how to decompose a 9. Remember, when you're doing a subtraction problem and you set up your chip model, you're only going to show the number, the whole in your chip model, because we are going to take the 9 away from 23. So we're looking carefully at the 23 like a detective to see what we're going to need to do in order to be able to do that. So I set my problem up with 23, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, sorry, I didn't do that right. It's 23, 10 and 20, 21, 22, 23. Sorry, I had to decompose a 10 because when I tried to take 9 ones away from 3 ones, I didn't have enough. So remember, when you're decomposing a number, you draw a 1 slash through it and you put those 10 ones back into the ones. So we're taking a 10 apart or decomposing a 10 so that I have enough ones to be able to subtract 9. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have enough to be able to take 9 ones away from 3 ones. However, I do have to show what I did in my chip model in my vertical model. And I'm asking myself the question, do I still have 2 10s? Not in the 10s, I don't. So I'm crossing out my 2 10s and I'm saying, well, you have 1 10 left. So I'm putting 1 10 up in my 10s. And now, instead of 3 ones, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. Are you remembering how to do this? It's been a bit. So now that I have 13 ones, I can easily take 9 ones away from those 13 ones. Remember, when they're going away, you have to cross them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. That leaves me with 1, 2, 3, 4 ones. So 13 ones take away 9 ones is 4 ones. And now I have 1 10. 1 10 take away 0 10s is still 1 10. Jennifer needs to have 14. Jennifer needs to have 14 more stickers. Needs 14 more stickers to have the same number as Katrina. That could either be written here, or you could have also written it back here, which I didn't because I wrote it on the front. Either place would be acceptable. If you were having a struggle with that word problem, it's probably because you might not have remembered how to decompose a 10. Got to be able to remember both because you need to be able to both add and subtract using the chip model. Okay, taking a look at problem number 1, you can see what we needed to do here. We changed 65 plus 75 into the vertical form. I did put a 0 into each one of those place values because I didn't have any hundreds, at least not to begin with. I didn't. Then I set 65, take away 65 and 75 as my 2 add-ins. The first thing I want to do is to make sure that I can compose a 10, which I can. So I drew a circle around my 10 ones and put it down below. If I do it in the chip model, I also have to make sure that I do it in my vertical form. We could get in that habit of making sure that both of those are showing up where they're supposed to. So that left me with 0 ones. I had no ones left after I decomposed. Then I'm going to look at my 10s and see if I can compose 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I certainly can. So I'm circling that. I am going to compose that 100 and do an exchange for this one. If I do it in the vertical, if I do it in the chip model, I also have to make sure that I record it in the vertical form. That leaves me, make sure you count them all, 1, 2, 3, 4. That left me with 4 10s. And when I'm adding my ones, or hundreds, I didn't have any hundreds to begin with. So 0 hundreds plus 0 hundreds plus 100 gives me 100. Therefore, I end up with 140. Okay. So now let's take a look at our next problem. Here we go. Let's take a look at that next problem. We have 84 plus 29. I put that into my vertical form and did all of the steps that I needed to do, making sure that I could exchange that 10, those 10 ones, and I put it into my vertical model, exchange 10 10s for 100, put it in my vertical model. When I got finished and added everything together, I ended up with 113. 1 100, 1 10, and 3 ones. 1 100, 3 10s. Oops, sorry, that's not 3 10s. 1 100, 1 10, and 3 ones, as Mr. Waldorf needs to say. All right, so your job is going to be to do the exit ticket and send that to your teacher. I hope you have a great day of learning. Bye-bye now.